Hello, good evening students. In last class we have discussed some important terms and constraints and output equation of DC machine, how it is directly related to the specific magnetic loading, specific electric loading, specific magnetic loading and specific electric loading. Hence, next important concept is there. I will take the class, don't worry. So, who are interested, try to understand and practice. See there, second important part is AC machine. So, either it may be induction machine, either it may be synchronous machine. This equation is common to both models. Hence, you try to prepare. I will take in the class once again, no problem. So, for derivation of output equation, consider a M phase machine. M be the number of phases. It may be 3 phase, it may be single phase, or it may be 6 phase. In general, consider a M phase of machine having one parallel path, that is one circuit per phase, that is referred as one parallel path. Consider Q be the kVA rating of machine. Q be the kVA rating of machine. This rating of machine should be equal to, in general, number of phases, output voltage per phase, current per phase into 10 to the power of minus 3. So, as per the above explanation, develop the equation. Equation number 1, Q equal to M E phase I phase into 10 to the power of minus 3. Here we are assuming the individual voltage per phase is equal to terminal voltage of each phase. So, what is the individual EMF per phase? We are already knowing EP equal to 4.44 times F phi m TPH and KW, where TPH is number of turns per phase, KW is winding factor, F is frequency, phi m is maximum flux. Develop the equation 2. And frequency, if N is taken as in RPS, revolutions per second, F equal to Pn by 2, remember, it is equation number 3. So, you have to substitute these two values, EP value and F value in equation 1. In equation 1. So, Q equal to M into 4.44, you substitute F value, F equal to P into Ns divided by 2 flux TPH KW IPH into 10 to the power of minus 3. You rearrange the expressions because I want to put in same fashion total magnetic loading and total electric loading. P pi one side you accumulate, second one 2 times of M IPH TPH, you make a group. So, here what is the IZ? IZ equal to current flowing through conductor, per conductor, that is approximately equal to IPH, because here we have considered only one circuit per phase. Therefore, IZ equal to IPH. Total number of armature conductors is equal to Z. So, Z is also equal to number of phases into 2 times turns per phase. What is the number of phase? M. Turns per phase, TPH. So, Z becomes 2 times of TPH into M. Hence, what is the second bracket you have taken? That is equal to IZ into Z. That is nothing but, sir, total electric loading. Hence, finally, Q equal to, we shall write 1.1 KW P pi IZ into Z Ns into 10 to the power of minus 3. It is becomes equation 5. 50% of derivation is over. Then Q equal to 1.1 kW write what is the P pi? Total magnetic loading. What is the Iz into Z? Total electric loading. What is Ns? Synchronous speed in RPS. It is the same fashion of DC. Hence, above expression represents in terms of total magnetic loading and total electric loading. Hence, we want in terms of active materials involved, that is d square L, volume of material required. Hence, we have to go for specific magnetic loading, B average equal to P pi divided by pi dl. Therefore, P pi equal to B average into pi dl. In a similar fashion, specific electric loading, it is AC equal to Iz into Z divided by pi d. You can go for Iz into Z, pi d into AC. Hence, we have to replace in above expression P pi equal to this value, Iz equal to Z value, then you substitute these values. So, in what we did in previous class, d square L n in DC machine, here Ns, n becomes Ns, d square L Ns, you keep outside, remaining all the things keep in one bracket, that is known as C naught. So, Q equal to C naught into d square L Ns. It is referred as output equation of AC machine, that is for induction machine, that is for synchronous machine. Remember, today only you practice. Out of these two equations, one may come in exam. Getting the idea? This equation is common for induction machine model and it is also common for synchronous machine model, sir. That's why it is very important. I will sending this video, try to go through this. Anyway, we are discussing in class. Thank you, sir, to one and all.